So you
Good.
Either way, you got that.
Do we all know how to remember?
R
So,
and then
but here
A.
it's completely different.
Yeah.
But I think it's supposed to be
First, second, third class.
Okay, good. If you don't know that by this
Was it
point,
First class? Oh, it was a
you have
second.
something to memorize. So this is your first, second,
No, yeah.
third, and then
I don't know. We haven't got it.
do you know what classifies all three of these? The characteristics of each?
I mean, flashcards.
So the first class is balance.
Right,
And it
so
could be
if the angle is right in the middle, then they're gonna be balanced. If it's closer to the
Mhm.
force, it's gonna have
Yeah.
increased speed and range of motion. You can remember it like scissors. And then if the axis is closer to the resistance force,
all the practices I did.
it's gonna be like a crowbar. And it's gonna be, or wait, the closer to the resistance will increase its force. That's
the
what it is.
force.
Good. Good.
Was it?
This
think
one
so.
is,
Because this is your insertions on calcaneus.
and this one is,
Is it
hopefully.
going this- is
So
it
what
going
I'm
this way or is it pushing it?
trying to get you to look
Okay, I
at
was thinking the other
and
example.
remember is the bulleted terms
The other
here.
example is pushing it, it's using the tibial,
So
which.
Oh,
speed and
yeah.
range of motion,
Yeah, you have the person-
those
yeah,
things.
this thing.
Mm-hmm.
You'll need to know those
Yeah,
things.
this one's third. I got that right.
Hmm.
This one was frustrating because I thought.
Third, I believe, is speed and range of motion, right?
It would insert past.
Okay.
Yeah, but then.
So know how to manipulate this,
And I can't remember why.
or like you were saying, and it sounds like you have that really good.
Can't remember it.
When you're
I can't remember it all for some time and it's gone.
Yeah.
So I
Corey,
just- I just
what
processed.
Hopefully it's just like one.
would each be defined as
You're getting-
using these terms?
No, I'm in 88.
the speed
That's good.
speed range of motion force. Using those
4.0 here, I
terms.
don't want to ruin it.
I'm giving you two situations, which one is speed and range of motion,
Yeah,
which one
it's
is
4.0. That's pretty-
force.
Yeah,
So
good
the
for
one
you.
closer, where the axis is closer to the force, that's for speed. Range of motion.
Okay.
Yeah,
And the other one is
it's gonna be
for
over,
force.
just last.
Okay, good. And then the other ones are more just
Yeah, it is nice.
specific to themselves.
It's only 55.
Now this makes sense too if we were to use our
Oh,
um,
no. Over all of them.
if we were to use our equation,
You probably read those things. No, we got them down.
if you
We didn't get through.
decrease this and you have a longer resistance arm, so hopefully you guys know by now that this is your force arm length in meters. This is your resistance arm length in meters.
Have you got this?
And then these are just values. So this would be what's in the muscle.
This,
This is what's the weight that is being the resistance. It's like 20 pounds. Usually they're both will be given in newtons,
ahead of time because
so that you can use these meters, because a newton is equal to kilograms per meter second squared.
Oh, wow.
That doesn't really matter. I'm just showing you that in this equation we're using meters, so our meters canceled it, so that we can solve. So when we have a small force arm, a large resistance arm, and let's say that our force is larger than our resistance, by this definition, we're going to have a lot of speed or a lot of range of motion, right? Now, if you were to decrease the resistance arm, so you're decreasing the resistance arm, and everything else being the same, if you're using that same force, and you're decreasing the resistance arm, that's going to decrease this side of the equation, right?
Mhm.
Because you decrease this. This was constant, but because you decrease this side of the equation decreases completely. Does that make sense? Okay, that's just algebra. So getting into the math side of things, really all he's going to do is throw
Can we do one?
values at you. Sure.
Like, is it gonna be like a word problem type thing? Like you're doing this and this is
Sure,
the rotation.
sure.
Can we do that?
I mean, I can't give you a word problem. I'm not going to write words up here. What I'll do is I'll give you a scenario and explain it.
But then this is, yeah, I'm not quite sure about this part. This part makes sense though. The really scapula working. You go into the arm so far before the scapula moves, right? So I understand that.
The scapula starts moving immediately. It's
Yeah, but only a smaller percentage, right? So.
So you should be able to derive that from any word problem you get. The reason why I don't want to put up a word problem is I don't have a word problem for you off the top of my head. I can't remember. Maybe those who have taken a test know what the...
There's an example in this book.
Is there an example?
Mhm.
Okay,
Give you the
well then I
notes.
would do the example.
Is that how you
That's
say
give you
that?
the nerve intervention. That's what it gives you in class. They say it once. I just-
So, no, this is 0.01, that's your force arm.
As quick as I can through the other ones.
yeah, they're on the car.
And so my resistance arm is X.
Okay, so like in those equations, you just have to remember like where
You,
things are.
yeah,
or,
so the
like,
thing,
definition
yeah,
of it.
that, as far as conceptually, you just need to know how to define these. If you can't define these, then
You're in trouble.
yeah, you're in trouble. So the resistance arm is always from the axis of rotation to where the resistance is being applied. Your force arm is from the axis of rotation to where the force is being applied, and that's the insertion point. In this case, obviously, we're looking at the bicep, and it's inserting on the radial tuberosity. So whatever that length is, and that length will never change unless it was surgically changed. But as far as manipulating the equation, you can manipulate it however you want. Just knowing that if you can understand that this is just algebra, and knowing how to define these terms,
Okay.
then you'll be good.
As long as that's what he gives.
This is the resistance it should be giving you. If not,
So we won't need to do
you'll have
this
everything
until
else given to you so that you can solve for it.
And
And then
this end part.
once you have solved for something, if he asks for further questions, he'll use the ERF